Hi, in this lecture we are going to go over some of the questions and concepts based on chapter 15, inference and practice. So if you read through this question regarding calculating power, the hypothesis is given to us and there a cola maker wants to test at 5% significance level the following hypothesis. So we know significance level alpha is 5%. That means that's a type 1 error that we are anticipating. That means we are 95% confident, and we know this null hypothesis is mu equals 0, alternative is mu greater than 0, so we also know that it's a one-sided test. Further reading, 10 test scores were used for significance tests, so we know our n sample size is 10. The distribution of test is assumed to be normal, first assumption met, with standard deviation sigma equals second assumption met, sigma equals 1. We want to calculate the power of this test when the true mean sweetness loss is mu equal to 0.8. So that means it's our more specified alternative hypothesis, because it should be greater than 1 0. If it is 0.8, what would be the power? But it's a stepwise process, so we have to consider two different questions in this case, or rather we have to answer that. So first subtype asks us to calculate the z statistics that would lead us to reject the null and corresponding um, x bar, that's mean, and they asked us to use inverse normal calculation to figure this out. And I'm just going to conceptually explain you why they say that we have to use inverse normal calculation. So for normal hypothesis testing, we first test state null and alternative hypothesis. Based on that, we would know whether it's a one or two-sided test, and then we'll use p-value or confidence interval to do the test and get the results, or either of this. And we know p is nothing but the area probability, and to get that area we have to find that corresponding z. Once we get the z by this formula, then making use of table b or c, depending on which way you're going, you can calculate p-value. And last step is comparing that p-value with the significance levels, that's the alpha or type 1 error that we anticipate. So in this case 5% of a significance level it's been given to us, so we are going to compare that with that, and if p is less than or equal to 0.05, we say we reject the null hypothesis, right? So that's the standard procedure. That's a normal calculation. So inverse normal calculation is because we have been given in this particular question stem that what would be the z statistic that would lead us to reject the null hypothesis. So basically we are saying that we are rejecting null hypothesis. So this is known, and then we have to go backward to calculate this corresponding z and corresponding x mean x bar value. So that's what is mean by inverse normal calculation. So now let's go over that. So we know p is uh, less than or equal to alpha, because we know that we are going to reject null. We're going to reject null hypothesis because we want to find a corresponding z value that would lead us to reject the null hypothesis. So our first step and for this particular question is, this is what we know. So alpha in this case is 5%, because that's 5% significance level is given to us. So p less than 0.05, right? So if you look at the z distribution, um, z distribution will give us the p value, and we know we compare that with some cutoff, that's the alpha value. So if the p value is less than that, we say we reject the null hypothesis. So this is how the scenario list looks like. So we have to find a z value that will correspond to this p value. So that's what we have to find. And similarly, if you transform that back in reverse fashion to the x distribution, so we have to find that corresponding x bar in x distribution as well. So that's nothing but the question that's been asked to us. So now let's solve this problem. So for the first part, I think it's just pretty much self-explanatory. We just have to understand the concept to find that z. So the test statistic here is nothing but c is equal to x bar minus mu upon sigma square root of 10. So we know these things, we don't have to solve this, but just for explanation, this mu is 0 and then 1 over square root of 10 that's given to us. So because we know that the alternative is one-sided because it is mu greater than 0, one-sided, we reject the null. We are going to reject the null hypothesis at 5% level, right? So whenever the alpha is going to be 0.05 or 5% or 0.05 area. So if we want to find the z, if we have been given this area as something greater than 0.05, because that area has to be less than that alpha. Uh, so we have to find that corresponding z value. So let's look at the 0.05 as an area value in table B, just like we used to do before using table B. So try to locate if you can find 0.05. Since it's an area, we have to go inside out. So we know 0.05 would be, this is 0.049, this is 0.048, this is 0.0505. So alpha will be somewhere, I mean z will be somewhere here. So we know the course value is going to be corresponding course value, and this is the additional find value, right? So this is 0.045, this is 1.6, so our z in this case is negative 1.645. Now it would be negative if the answer would be negative because we are looking at p table always gives us, so table B always gives us area left to the z, so we get this area, this particular negative z, and when we look at 0.05 here, but we are looking at particularly hypothesis which is on the greater side, because we are saying on hypothesis, alternative hypothesis mu is greater than 0. So we will be particularly highlighting this tail, right? And we also know that this is symmetrical curve, normal distribution. So this is going to correspond to this positive value. It's only going to have this positive value, and the area is going to remain same. The value of z is also going to remain same. So if table gives us this as 1.645, then this corresponding z is going to be positive 1.645. And that's how we say our z is going to be greater than 1.645, right? Why greater? Because if you look at that, if you look at the first step, we reject the null. That means p has to be less than that. So p has to be less than that. That means the area, this black shaded area, has to be less than the area till this red line. And that means our z is going to be greater than that, right? Because on z scale, if you look at, this is 0, this is positive, number is going to increase as we go further on this right side. That's why we say z has to be greater than 1.645. So that's the first part. Now let's find the corresponding x value. So that's the first part of A. So we are still in question A. We did the first part of calculating z. The second part of A is calculating the corresponding x value. And to find the value of x that corresponds to the z value, we can calculate that by uh, comparing simply this z with the critical z, z star. So x, we know z is nothing but x. Let me just write it here. So we know z is equal to x bar minus mu upon sigma square root of n, right? So based on that, we know null hypothesis, um, for null hypothesis, our z is going to be x bar minus 0, because mu is 0 in null, 1 upon square root of 10. So that has to be greater than this particular z star, that's the cutoff value, right? 1.645. So which is x bar greater than 1.645 times 1 over square root of 10. So you're just solving the equation here. It's just that we don't have equal sign here, and we know the reason why, because we're comparing z value with the critical z, right? Because to reject the null hypothesis, our z has to be greater than that cutoff value z star, right? So, and if you solve that mathematically, you are going to get the answer of x bar that should be greater than 0.5202. So that is the x bar that we are going to get when we reject null. So when we reject null, that's the x bar, and when we reject the null, that's the z value, right? And we are not going to get definite answer, because simply it can be anywhere, probability is anywhere less than or equal to that particular alpha level. So we are going to always have answer like this, right? It could be anywhere further z or x score on this tail, but that's the answer that we expect, right? So now let's look at the part B of the question. And part B asks us to find power. So when true mean sweetness is mu equal to 0, how often we reject the null? So true mean is nothing but alternative. So in this case, our alternative hypothesis is mu equal to 0.8, and our, oops, this is alternative, and null hypothesis is mu equal to 0. Right? So it is asking you, now read carefully in this particular question, and I just want to highlight what they are asking. So when the true mean sweetness is mu 0, that's nothing but alternative. So how often we reject the null? So how often we reject the null? When the true mean is nothing but alternative, that's mu equal to 0.08, how often we reject the null? So that is the cell that we are referring conceptually, and that's nothing but the power of study. So that's basically saying that we have been asked to calculate the power. Go back again, pause and go back again if you are confused with that particular 2 by 2 table, but I think this will further clarify. That is what is the probability of obtaining sample average, like the ones defined in A part, when mu equal to 0.8. So use table B. So instead of that, we are going to just refer B. I'm going to show with that, because we have to stick to what we have covered so far. Using that table, calculate this probability. This probability is power of test against the alternative hypothesis, mu equal to 0.8. The probability of rejecting null when the alternative mu is true. So probability of rejecting null, probability of rejecting null by us based on sample when the alternative is true in population. That's nothing but the power, right? So that's a little bit explanation of concept. So we want to find that particular probability or power. So let's solve that in here. So we know that we are looking at mu when mu is equal to 0.8, and we want to find probability when we reject the null hypothesis in this case. So that's nothing but probability of x bar being greater than 0.52, right? Because we found that same probability corresponding x value for that to reject the null is 0.5202, and they ask us to refer to that probability from what we have calculated in A. So if you transform that x to z, because we know that making use of any of the table we cannot find probability for x value, so what we do is we transform these x values to z values. That's why let's transform that to z value, and z would be nothing but so we know that z is x bar minus mu upon sigma square root of n, right? So this is what we know. So based on that, we can fill in, we can write the corresponding z values for these two sides of the parenthesis. So x should be greater, x bar should be greater than 0.52. So for, so when we reject the null, that means we are specifically looking at the alternative hypothesis being true. So x bar minus mu in this case is going to be what we have in alternative, that's 0.8, and sigma, rest things are same. So you can see that this should be corresponding to 0.5202 minus, again that's the x bar, and mu is again 0.8, because we are saying that we are rejecting the null, and the rest of the things remain same. So if you solve this particular part, then you are going to get the answer as negative 0.88, and that's nothing but the z critical value. Right? So you're going to get the probability being z greater than negative 0.88, and that probability, that z, that probability we can find based on that z value by referring to table B just as before. So we just have to find that particular area. So again, this is table B, negative 0.88, that's what we got. So negative 0.8, and then fine is 0.88, it should be somewhere here. Okay, this is 0.88. So that is the value. So 1.1894, right? So we know 0.1894. So 0.1894 is the probability on the left side of that z, right? But if you look at this particular power is nothing but z, whenever z, so this is, we know that this z is negative 0.88. By table B we got this particular area probability, that's nothing but this tail area, and we want to find probability that is greater than this negative 0.8. So basically we want to find this dotted shaded area. So we have to subtract it from 1. Therefore that will be 1 minus 0.1894. That's the tail. And if you solve that, it should give you 0.8106. So therefore we say that the power of this test against the alternative hypothesis mu equal to 0.5, 0.8 is 0.8106. So that's our final answer as power.